we are going to discuss the color of different coordination compounds. We already have discussed that d orbital containing species like transition metals can show different colors and different types. So when some beam of white light just falls on a surface of a coordination compound and some of the light is absorbed and the remaining part is reflected from that coordination compound, and we show either different color or in sometimes it shows no color, it becomes colorless. So when white light is just falls on a particular surface or a particular position of surface of coordination compound, some of the color of the white light get absorbed. If the light absorbed is red colored, then we can observe the complex of the color will become green. Just like if yellow light is absorbed, we get violet coloration of the complex. If bluish green is absorbed, we get reddish violet. And again, if UV light that is not in the visible region is absorbed, we get pale yellow color. If blue light of the white light is absorbed, we get yellow orange coloration of the complex. So different color come from the different complex with different color absorbed from the visible light region of white light. So again, color of the complex, color of the coordination compound is due to two factors, that is DD transition and electronic transition or charge transfer. That is charge transfer. But here we will only discuss about DD transition. That means electrons jumps from T2 set to EG set in presence of ligands. Actually, we have already discussed there are two types of ligand. One is strong field ligand, another is weak field ligand. Strong field ligand creates such a field that all the electron gets paired. So we get low spin complex. We have already discussed in the previous classes, and this DD transition we are going to discuss about electronic transition from T2 set to E set. That means dxy, dyz and dz orbitals, and from which electron jumps or excited to dx square minus y square and dz square orbital. Okay, again this color is due to DD transition. If there is no DD transition, there will be no color, so we get a colorless coordination compound. Where there is no DD transition, we get a colorless coordination compound. Is it clear?